That's a good idea. That way we get the higher resolution and not the 708p that Twitch puts up. Weird resolution for some reason. All right. So what we're going to go over today is more UML. So we left off here, and we are going over the various types of relationships that we can have. Again, composition and aggregation were the two that we were kind of digging into. And if we recall, the big difference between these is that if you're composing something in UML, you have to destroy all of the child objects that go with it. So if we have a school class and it's composed of multiple departments, we have to call department.destroy when we call school.destroy. Aggregation, we don't. The classes are in charge of themselves. They can live on in memory forever. Other interesting things to keep in mind that we hopefully remember from last time, we have multiplicities, we have labels, so we can kind of decorate these relationships as we go. So again, asterisk is many, dot dot means a range, straight up number is just that amount. This can be useful when we're programming, when we're trying to figure out behaviors and how many things we are allowed to instantiate at any given time. What else do we have here? We have straight up relationships, meaning there's some sort of a linkage here. And I think that's all of the interesting aspects to this particular model. Obviously, we have labels, and we've got this little triangle here, which is just a label. It doesn't really mean anything outside of like meaning to you, the programmer, not like a formalism, I suppose. So we have that going on, and we can now continue on with our stuff. Here's another example of association, aggregation, composition. So here we have a team that is putting together a airplane. So a team has multiple employees. If the team goes away, the employees do not go away, right? So we're going to keep them in our company. They can build an airplane. So one team builds one or more airplanes. Airplane has a composition of components. All right, we see its composition again, filled in diamond. Components are made up of subassemblies. And in this particular example, right, components would destroy themselves if we destroy the airplane object. So just kind of more examples to get you going with what association, aggregation, composition are. But if you, again, if that doesn't make sense, please feel free to stop me and ask. But hopefully that makes sense. Big umbrella activity and then a bunch of like subcomponents is what we're building here. All right, so the next thing that we are going to talk about is a realization, and I promise we are actually getting kind of close to the end of all these relationships. Did mention there were several. So realization is where we generally have an interface. So we are going to specify a contract, and a contract is actually a formal thing that we can define. I'm going to guess that at some point in your Java careers, you probably have defined an interface type of a class. If you haven't, um, it's basically a nice little API type of a thing. But what happens here is that we're going to define an interface, and we specify some kind of a contract that another class will have to carry out. So basically, this contract means that we are delivering a particular service in a particular fashion. All we're really doing is like constraining this class on what it's allowed to do and what it should be doing. This is all really, again, just kind of layering on top of our programming techniques, right? A contract is not necessarily something that you need to do in, C++1 or Java 1 or whatever, but this is where we are starting to really formalize what our software systems are doing. If you don't have a contract, I mean, that's fine. That's up to you, the designer, to ensure everything that, it's all called correctly. But if you formalize things, then say other people that pick up your project can't violate these constraints, for instance. So this type of a relationship here, and I've got an example on the next slide, dashed line, open arrow, basically the interface is in B, the actual class is in A. So what we've got here is a interface type of a situation going on. So we have a rule agent, and I don't have any hidden notes on what this class is exactly doing here. But you might have business rules, for instance, to kind of go with this figure where, maybe you add a new project, you add rules that define a project, kind of more businessy things. This could be, a game agent where we're adding artificial intelligence logic to our entities, or we're constraining animations or something like that. Basically, we just have a list of methods here, and this particular class has a realization with this interface, meaning that we have to basically follow out what this interface is providing for us. So let's see if we have another example here. Trying to see if I have a better example. I don't think I have another one. And now this is frozen. Okay. Mouse works, arrow keys don't work. Basically, it's how you link up with an interface is really all it is. So if you need to define an interface in your Java classes, boom, realization. Why are arrow keys not working? It's really hard to swig coffee and move slides. Oh, we do have a realization here. It's in Lollipop notation. I forgot about this. So here we have a full-on class diagram. So this is kind of putting everything together, right? We have compositions, we have aggregations, we have realizations, we have dependencies. And so this would be similar, our realization from the last slide, except it's a different notation. Let's throw in more notation at you. We love new things, right? So here we have a person, we have some tax records, a company. Clearly this is a business-oriented diagram, like we're trying to set up maybe an ERP system where we're defining entities, offices, cubicles, meeting rooms, people, everything that we need to define. And what we see here, and I'm just going to kind of zero in on a couple things, and again, kind of assume that you hopefully remember class diagrams from the last time. I mean, if this is unclear, please stop me and ask questions. But we have a personnel record class here. So we have a person class, and if we want to get their personnel records, well, we have to talk to the personnel record class. Personnel record means you have a tax ID, maybe you have like an employment history list, your current salary, or a list of salaries if you've been around for a while. And this talks to a interface here, I secure information. Now this notation is called a lollipop notation because it looks like a sucker. Basically, we just have this interface is kind of in elided form. It's not necessary to be represented here. It's just kind of a generic blob. But we have a interface realization that we can basically work with these records in a secure fashion. But the details are abstracted away from us in this figure here. Is there anything else interesting to talk about here? Because otherwise it's just more of the same. So we have this little dependency dashed line here. We haven't seen this yet. So we have this dashed line, and it's a subset. And how we would read this is that if we have a department made up of a number of people, we can actually have two different relationships for people in here. So a person can either be a member of a department or a manager. And a manager is actually a subset of people. And what this means to you, the software engineer, is that we just have one person class, right? And we would instantiate this for however many people we have. But if they're a manager, they might get like a special tag or a special attribute. And we would only ever allow one manager per department. A manager is a person, which is debatable depending on your management and your opinion of them, but you only get one. Whereas members, you can have at least one to any number of them. But other than that, I think that's probably good. Oh, we have stuff here too. I forgot about this. That's why you remember what your animations do. So if you need a good like overview of what all of these various relationships and attributes are, this is a pretty reasonable slide to kind of come back to later on. But makes sense, hopefully. I've got some questions for you now, for hopefully people that are paying attention. When would you use a class diagram? So I'm giving you this overload of information, expecting you to say, oh my God, this is absolutely necessary, right? But when would you actually use it? So question to you all. And I see that I have at least 17 people in the chat currently, meaning that's probably out of date already. So I know you're there. I can see you through the camera. To present a project to a person with money. Ah, I love the cynical view. Makes me happy. I'm having a positive impact. Oh God, have I done this all to you, or is this already built in? When your boss tells you, okay. During the design phase and towards the end of writing the program. Yeah, so both types of answers here, time-wise and purpose-wise, I suppose. So class diagrams, we definitely do. I guess maybe let me step back because every single process will have you do it differently. When you have a team of people working on a project and they need to use the class, that's a less cynical answer. So thank you for that. Um, yeah, so typically you do it when you have requirements in hand and you kind of know what you're going to be building, right? So this is generally the step before programming, depending on your software process model, right? Organizing teams for projects. Sure. Yeah. And we do it for multiple reasons. So, team of people working together, a nice, easy to understand diagram helps everybody understand what has to be programmed, right? So if we, let me go back here one. If I, let's get rid of all this stuff. If I give this diagram to all of you, you know pretty much what needs to be constructed, right? We know that if we create a department, it's going to have a name. The name class, or sorry, the name attribute's probably going to need a getter and a setter. And then this is just a class in memory, right? We can do whatever we want with it. Same with the rest of this kind of stuff. I know that if I want to say implement the person class, I need to implement other classes to kind of normalize their, you know, or sorry, separate out their concerns. And even if you go down this route where we have something abstracted out, we know that our personnel records here are probably going to have to reach out to some kind of a secure module, securing module. Maybe we're like encrypting and decrypting it. But if I need info on how to secure things, I probably would look to another class diagram or requirements or something like that, right? So yeah, communication purposes really very clearly tell your team and any stakeholder what you're programming. So another question for you then. If we are using Agile instead of Waterfall, does that change class diagrams at all for us? Does that change the purpose or when we do it? I guess it's kind of an open question for you to think about. Some kind of a creature outside. Not necessarily. Good answer. So yeah, I mean, depending on your process, and I should say that I've been kind of talking these models through in like a waterfall type of idea because that's the canonical standard of sequential processes, right? And it's easy to visualize. But with Agile, you could build a class diagram before you start doing your project, and no issues with that. No, but it would change when they are made and when they are updated. That is true too. So if you decide as your Agile team strategy that you're just going to go right in, say do like test-driven development or something like that, maybe you build the class diagram as you go. Maybe you build it right before you program. You know, you get your stubs in for all of your functions and all your tests, and then you update it as you add parameters. It just depends, I guess. Again, this is the class of trade-offs. Does it make sense to do it before or after? Does it make sense to do it at all? One last question. So we haven't talked about this one specifically, and I want you to think about it. So let's say that you have a code base, right? You have built our ERP system with our employees and our records and our departments and all that. Does it make sense to generate a class diagram from code? And the extra information is this is absolutely possible to do with current IDEs like Eclipse or IntelliJ. May need a plugin depending on the system, but you can generate class diagrams automatically. I know those of you that were talking about ER diagrams last time, if you're using something like SQL Server and that GUI interface, you know that you can automatically generate those diagrams from a list of tables. It's the same idea with class diagrams. But are there any pros or cons of doing this? Yes, does the question make sense? Possible bugs in the code doesn't account for code that needs to be written. Sure. So maybe if we generate a class diagram from our code, see if your predicted is what you have. Yeah, absolutely. So you are all, budding programmers, right? May help the customer as well. Yes, so definitely a good point too. Again, communication purposes. As programmers, sometimes we think that we have done a perfect job programming, um, and that's not always the case. It's very usually not the case, honestly. Um, and automatically visualizing your code can really help you zone in on issues quite a bit faster and establish this. Yep, so you might have overlooked something, have the big picture in one spot. Yeah, you all get the pros of it. That's good. Um, and this can show you if you have screwed up unintentionally. Right, let's go back to our diagram here and get rid of all the fluff. Let's say that we have generated a bunch of code, right? I had you all build this project and works fine. This is a terminal-based project where, I give you menu options, or you give me menu options. One, create company. Two, create department, add person, all these things, and it's filling in spots in memory with these classes, right? Well, then, you know, I say, okay, let's get rid of this department and or sorry, let's get rid of the company and start fresh just because we want to, maybe build another company. Maybe we're a contractor for SAP. That's the big company for building those enterprise-based programs. Well, let's destroy company A because they folded, they lost their venture funding, and we don't need to track them in memory anymore. Well, you made it an aggregation instead of a composition by accident. Class diagram would tell you that code might be hard to dig into. And the issue is when you destroy that company, you leave all of these dangling bits in memory, which can suck up resources. Again, just kind of a visualization thing. And that can help you. Some of the cons, though, I mean, they're not perfect tools either, right? Automatic generators always are going to have some issue. They're not perfect. So they might generate kind of false positives in a way. But yeah, I'm glad that you all kind of at least get the notions here. So now we are going to move on to object diagrams. And this is what Unsplash Images has for me for object diagrams. Have any of you ever generated an object diagram before? I'm hoping that you have because you've done class diagrams. I think when I asked this question last semester, nobody had any idea what I was talking about, though. Not to my knowledge. Okay, good. Let me give you the spoiler. If you have done a class diagram, an object diagram is very, very easy. Yeah, I'm unsure. Cool. So a object diagram is just a realization of a class diagram. So take your class diagrams that you built, create some object, like in the construct of this class diagram. That's your object diagram. So basically, this is showing you what you're actually instantiating in memory, and the relationships that exist at some point in time. And the point in time is basically just meaning that, okay, we have realized this diagram. This is what things look like currently. So this is where we are taking the class diagram that you have slaved over and that you've, put all this effort into, and let's just use them and create something, okay? So again, this is a static diagram. We don't have dynamic behaviors yet, but this is, I think this is my favorite example of how to visualize this kind of thing. So on the left here is our class diagram. So you have your dog, nice little cutout. You instantiate it, it's an object diagram. So you're basically just filling in the blanks. So you have your dog class, right? You have a color, you have an eye color, height, length, weight. The dog can sit, lay down, shake, come, roll over, play dead, all your fun favorite dog methods. And if you're not a dog person, you should be a dog person. If you're a cat person, that's fine too. But I don't think you can necessarily teach them to play dead without lots of heartache and scratches. Um, but yeah, you have your base class diagram. Yeah, exactly. You're instantiating it is the proper term for that. So yeah, you're filling in the variables. Okay, so I'm going to create a dog. Call it Bobby. It's a yellow, probably a yellow lab or something. Brown eyes, 17 inches, 35 inches, 24 pounds. I still can tell it to sit and lay down and shake and, come to you. Things like that, right? This is basically just proving out your class diagram. Do we have all the proper attributes to describe a dog? Do we have all the proper methods to describe a dog? So you can take the other example here where we have our company-based diagram, right? And this is all the fun stuff that comes with it. Well, let's realize this diagram now. So we're going to have a company C, and these are kind of boring object names. We're going to have two departments, okay? So sales and R&D. Our department sales might have a subdepartment. So that's possible in our particular view, right? So we have this composition here where a department can be made up of multiple departments. We have our relationships here that we are seeing. Okay, so this particular department has one manager, right? We don't necessarily need to show everything, but here is a class person with the attributes filled in. And you can kind of see what your class diagram is going to look like in memory once you instantiate it. Again, this is just a graphical version of saying C equals company, okay? D1 equals department, parenthesis, sales. So we're getting a visual for what's actually happening here. And honestly, there's not a whole lot that we need to go into with object diagrams other than realize that you are just visualizing how you're going to be calling these classes. Right? So hopefully it's pretty clear the purpose of these. And we can have, anonymous objects as well. And the distinction is that here we basically see, this is effectively like the variable name or the ID of the object. So D1, C, D2. We can reference these objects if we need to. Here we don't have that in front of the class name, so it would be anonymous, meaning that we don't need to really like instantiate this. Or if we do, it doesn't impact us at all. And the reason why I'm kind of highlighting that is we're going to see this when we talk about sequence diagrams and message diagrams. We're going to see this kind of same notion here. All right, so same questions. Why would you use an object diagram? Does it make sense to use an object diagram if we have a class diagram? Or is it extra effort? Does the question make sense, I suppose? Give a client a running example. Yeah, that would be one thing that we could do, sure. But for you as developers, right, these tend to be internal diagrams unless we need to talk to somebody about it. It'd be good for snapshots or to have a review of the project after some development. What if we haven't done any development yet? Example that would work for testing. So yeah, I mean, your answers here are all perfect. But let's say that we haven't written any code yet. We're going pure sequential, you know, doing our UML diagrams, and then we're going to do coding. Does this exercise help us? Layout of what should be called what? End product relationship ideas. Sure, sure. So this step, let me bring in a term that we haven't really talked about yet. This is a great way to validate your models. So let's think of our class diagrams as a entity that we need to prove out. No, that's fine. It's an open question. I mean, it's not, there's not one right answer, and you are all answering correctly, so don't feel bad. Um, I'm just trying to get you to think about why we might use something like this, because it's not, if you go into industry, this is not going to be a thing that's just a requirement. It's going to be sometimes an extra effort. But if we go through the process of instantiating our models, we're actually validating that our class diagram is correct. Okay, so if we go through, and I know I keep losing focus here. Let's say that we want to have a animal class and a dog class, and we have spent some time, we get together in a Zoom meeting or in a conference room, figuring out, okay, we're building this amazing MMO type of a game, and we need some animal classes so that we can randomly spawn mobs for you to go take care of. Okay, well, what does it make sense to have property-wise and method-wise? Okay, well, we've hammered out this class diagram. It's perfect. It's beautiful. We have these wild dogs running around. Well, let's instantiate some of them and see what we can do. And let's say we haven't written a line of code yet. Well, we can instantiate Bobby. We can instantiate a million other dog names. This is the constraint. These are the constraints we're working with. Well, what if we want the dog to run? Or we want the dog to jump? Or we want the dog to bite? Well, we don't realize that until we get to this point, because we are now like kind of visually playtesting or visually testing things out. So, we can put together everything we think we need, and then we actually go to start using these objects. We might be missing stuff. Well, then we go back and fix the class diagram, or we go back and fix the code and the class diagram. Really, it's just kind of a walkthrough to make sure that everything is what we need it to be, right? So it's kind of a good validation step. Software process change? No, not really. I won't make you answer this one again. But this is kind of a nice question to at least talk about here. How many object diagrams are there for each class diagram? Well, there's a simple answer for this. As many as it takes to get the point across, right? So if we have a single instantiation here, we don't necessarily get the full picture. Maybe we need a dog to do more than sit and lay down and shake. Okay, again, maybe we need it to run. Well, we possibly might not be getting that just from this single object diagram. Or maybe it is enough and we show the customer this, like one of you said, I think 4 or 5 points ago. This is an example of what we're doing. Are you happy with it? Yes or no? So basically the idea is, again, communication and validation of our models. So good, thank you for playing along. I like when we can kind of think through the purpose of some of these things, because I can talk all day about the syntax of them and, okay, you have to do this and this and this to make it a perfect model. But if we don't actually understand why we're doing it, it's kind of a pointless endeavor, right? So they can be useful. Think of it almost like rubber duck debugging in a way. I'm going to work through a model, which is not actually code, but I am in a different venue. I'm looking at a piece of paper, or I'm looking at Visio or something like that, and now I can kind of hopefully visualize pieces of my little puzzle here. different medium to work through helps out sometimes. Okay, so enough class diagrams, enough object diagrams. Let's move this train along here. Let's talk about dynamic models. So we're going to go over sequence and message diagrams here. Basically, we're going to be handling timing-based things happening. And we're going to organize the time ordering of messages. And all a message is just some kind of a sequential interaction. Doesn't have to be like a packet with the destination. It can be that we are instantiating an object, or that we are sending data to another class, or that we are moving through the flow of our program. Basically, just thing is happening at a point in time. So a sequence diagram is basically going to have objects arranged over the X and Y axes. And I'll give you an example here in a second. This is probably one of the main models that people think of when we talk about UML. So before I dip into that, we've got a couple of things. So there will be a lifeline, which is basically a dashed line that means this object is alive, meaning it's instantiated. And then we're going to have a focus of control or an execution window. Depends what you want to call it. There's multiple names for it. But it's a thin rectangle that shows that the object is doing something. And I'm explicitly not saying X and Y axis here because depending on your model, depending on what you want to show, you can flip it around. So you can go portrait or landscape mode depending on what you need to show. But this is a typical sequence diagram. So we have some information here to kind of go over. All right, and I'm going to walk you through this example because it's kind of a nice way to get into it. Is this example based? But these vertical dashed lines here, that's the lifeline for each of these. Each of these things at the top is some kind of an object. So think of this like we'll call these swim lanes as well. Basically, everything on this vertical is our friend Osbert here. I just grabbed this off Google. This is not my figure. Osbert's a great name, though. Here we have a user interface class. Everything on this vertical line is the user interface. Same for compute, same for masterpiece, same for auction painting. So this is by the way, this is like an art auction with a computer system running things behind the scenes. But vertical here, and where I was talking about before, if you wanted to flip this so that all of your objects were along the y-axis here and time was kind of on the x-axis, that's perfectly fine too, just so that you're aware. But the way you read these is you start at the top left and you go down and right. So basically, go down and follow the arrows. That's the easy way to read this. So we start life up here. Osbert is an actor. So we see the stick figure. This could also be a system, right? It doesn't have to be a person. It's just some entity interacting with us. All right, well, first thing that's going to happen, we're going to go down the lifeline. We see our execution window here. So basically, Osbert, the entity, is alive during this little thin rectangle. So we would call Osbert equals new person, parenthesis, Osbert. Then he's alive at this point. Well, he wants to bid on a masterpiece, so on some artwork. So he's going to give some details to the user interface class. And we see two different figures here. I'm going to be less uppity about this particular model syntax here. Basically, this is a class. This little line here means we have a boundary. So there's a system boundary here. If it doesn't have a line, it's just a general class object or entity. But so we're going to call a function give masterpiece details. So we start here, we're going to do this. We then interact with the user interface. The user interface passes this information over to a compute price class. The compute price class is going to instantiate a new masterpiece. That object is going to be returned, and then we're going to be able to browse, all of the auction paintings within this realm of information. Again, just kind of a high level random example. Like this doesn't have to be artwork, obviously. It can be, instantiate your simulation, pass in a noise function, generate timing, whatever you are doing here, right? But we're showing the classes that are involved. We're showing at what point in time they are interacting, and we're showing what's happening to get from point to point to point. All right, so we kind of see here going this way. Let's create an object. Let's return that object. Let's browse everything that's available. Let's get the particular object we want. Okay, that object is going to have a price. Provide that. What does it mean to provide price? Well, we're probably like calling get price from that class that we're returning. Well, okay, so now the user interface class has the price. Let's display it to the user. The user is going to, in this particular example, maybe I don't like that price. Maybe we're doing a, again, this is an auction type of thing, so like an eBay. That's too expensive, I don't want to buy it. So reject it, destroy this class object, and the sequence. So again, the too long didn't listen, start at the top left, follow the arrows. That's going to be the easy way to kind of walk through one of these. I've got some more examples here too. And other things that we are going to see. So let me go to a different example here. Actually, here I've got the legend. So actor can be a stick figure, or we can do it like this. So in a box, just so that we don't have multiple figures, but you want to put bracket bracket actor. This is where I kind of talked about anonymous versus identified objects. So here we have like an instantiated object, colon, the class name. In this figure here, we just see blank, colon, class name. So these are all basically anonymous objects. We could instantiate them as specific objects too. So like when we go back here, right, these are all specifically instantiated objects. This is anonymous because we don't have a named class basically. So we can do all that in here as well. Okay, so we have that. Let's look at it. I've got a little example here about what this boundary means. Again, I'm not going to be too upset about it if we leave that off here. But here's another example. A little bit simpler, honestly. So here we have a customer, an ATM, and a server. So this is basically a bank card type of thing. You walk up to the ATM, get some money out, walk away. All right, so we have a customer. All right, so the customer has a class. Customer is going to put the card into the ATM. The ATM is going to check the card date. Not sure why we're flipping between English and German in this figure, but put the card into the ATM. ATM will check that the card's okay. Pass that detail over to the server. Server returns a response. ATM will either give you money or not give you money. We don't necessarily have all that detail here, but we are showing kind of the interactions that are going on. And this figure is a little bit better in terms of the syntax as well, because here we see an interaction, solid line, dashed line, we see the return value. So that's kind of what you get from this figure. All right, other things that we can do as well, and that's going to be on this figure, which is a little bit blurry, but you can add on guard conditions as well to these lines. And these are basically just constraints to allow that interaction to happen. And what's an interaction or a guard condition? Or sorry, what's a constraint or a guard condition? It's just an if statement. All right, so if we go back here, sorry, let's go here. This is going to be making a doctor's appointment. So you can kind of see here, a patient exists. That's the guard condition. So this check would be if num patients is greater than 0, this is true. If we have 0 patients at this practice, it's false. We don't have any way that we can look up information here. But basically, again, the takeaway is we're showing communication. We're showing sequential communication between objects in our system. All right, so if you are doing your class diagrams and your object diagrams, you get no notion of time and behavior, right? Here we're actually showing that behavior. We're showing the first thing that happens is that our customer interacts with the system. Next thing that happens is the ATM takes that information, transmits it to the server. Then we see that the server processes it, returns information. Again, things which we can infer from requirements, from class diagrams, but we don't have a specific way of showing that until now. So this is a great visual for timing and dynamic behavior. And again, if you are getting lost in the model syntax, I've got these figures here, which hopefully are helpful for you. But let's take a look at this this interaction here. So we want to make an appointment at a doctor's office, something very relevant to current times. Let's make an appointment for a vaccine. So I also should mention check Spectrum. I got an email saying they got a bunch of doses again. So hopefully, people that missed it last time can get in. But we have a patient, we have a receptionist. So these are two actors, right? We could also make them boxes and put angle bracket, actor. So a patient wants to request an appointment. Well, the receptionist takes that information and calls lookup patient. All right, so if we get a patient, so here we have our a patient. If they exist in our system, okay, we're going to go here. The return value is implied. So I should step back because not all of these have return values that you're looking here. So lookup patient, we don't see a way back. And that kind of conflicts with what I told you to follow the arrows. If we have a very simple call, the return is implied. It's just to save on drawing extra lines and cluttering up the diagram, basically. So if we're just calling like a get function, it's implied that we're returning this object or something like that, okay? So lookup patient, implied return patient object. If a patient exists, meaning this person exists in their database, look up their bills, okay? Another get function that's implied. If we have unpaid bills, return that set of objects to our receptionist class. And then we can go back to the person. Hey, do you want a new appointment, cancel or change your appointment? Here's a list of the appointment times. Basically get calls to this first entity, right? So we're going this way now, going this way. If we have a positive response, again, kind of implied here, well, the receptionist would then match appointments or create appointments based on what we have in our components or our appointments class. We can abstract things out. My suggestion for you all would be to put the return values in until you get comfortable with these kinds of diagrams, because then you can be exceedingly explicit with what you want to show, right? As I'm kind of describing this figure to all of you, I have to go back and explain, well, it's implied that this value is coming back. And if you ask me, the anal retentive software engineer, about this, I would say absolutely you should put the return value in here because I don't want to have to explain every single time what the return value is, if it's implied or not, right? So basically, I just recommend putting the returns in there. But we can also see in here a little bit of parallel behavior as well. So maybe I don't want, to run this function. Maybe I just want to get appointment times. That's a possibility here as well. So maybe I don't actually need to call this, right? I could possibly run these in parallel if this is, a function call instead of a, face-to-face interaction. So let's, I'm going to assume that you can figure this out, and one of your assignments will be to generate a diagram like this. But the important thing to talk about before we run out of time is the process for building them. Okay, so first things first, let's set the context. Well, what's the context? The context is basically the entire purpose of this interaction. So first thing you have to figure out is exactly what you want to demonstrate. Here we're making an appointment. Here we are interacting with the ATM and getting money. Here we are getting or making bids on art auctions. Who haven't I picked on yet for term project stuff? First-person shooter multiplayer game team. I don't think I've talked about your project much yet as an example. What's your context that you want to model? Well, let's model out shooting your gun. Okay, that could be an interaction. Well, that's my context. Okay, what's the actors? You need the player, you need the gun model, you need the interface with the keyboard or the mouse. User picks up gun. User reloads gun. User triggers the fire function. Bullet is displayed on screen and bullet's position is updated until it either hits another player or the environment. Right? We're showing the exact sequence of operations here. So we set the context, we figure out who is interacting, right? What are the actors? Is it you, the player? Are there some other entities? Kind of think about back to your use case diagrams where you added those, stick figures on the outside of your use case diagrams. Similar idea here, except we can also include classes now. All right, so we can include the internal pieces of this puzzle that will actually be doing something. Next, set the lifeline, which is basically, again, that vertical line. How long is this entity alive, quote unquote, alive in our system, meaning it's instantiated? And then figure out what is the sequence of events. Show how data is passed. Show your guard conditions, right? Going back to the multiplayer game example, if I want to fire a bullet out of my gun, what's the guard? Well, I need bullets in the gun's magazine, or I need a gun in general. So if player has gun and gun has bullets, then fire. And again, you can exclude the obvious return values, but I would recommend adding them in just for clarity's sake for you all. All right. And then validate it. So what does validation mean? Just walk through it. Make sure that it makes sense. The same idea with validating your class diagram, turn it into an object diagram. You show it's working. How do we validate a sequence diagram? Well, walk through it. Are we actually starting with a patient, or are we starting with something else? Does it make sense for the receptionist to be here, or can this be some other entity? Do we need to look up unpaid bills, or can we just go right to appointment making? Right, kind of walk through the sequence of events, make sure it makes sense. All right, so that's going to be it for today. Next time we'll wrap up communication diagrams and we will move on. Questions at all? And if we're good, see you Friday. Yep, have a great day. Don't forget tomorrow is your other vacation day off. So hopefully you get some good respite in. Bye, everybody.